Okay, most welcome everyone to the seminar, Integration of Agriculture and Aquaculture, a key concept for future food production. My name is Anna Norman-Havén. I work as coordinator for SLU Aquaculture, and it is a platform with the aim to strengthen aquaculture research and education here at SLU. This seminar is organized jointly by SLU Aquaculture and SLU Future Food, which is one of 4 future platforms here at SLU. Future Food works with research communication and with strengthening collaboration between disciplines within SLU and with external actors. Their vision is a sustainable food system. The program today starts with an opening seminar and we continue until 1 o'clock. And we will have a presentation by our invited speaker, Professor Barry Costa-Pierce. After that, we will have a short break. And for those of you who would like to gather again for a more in-depth discussion, we meet here again directly after the break. We will take some photos today, but if you do not want to be in any of those pictures, kindly just inform me during the break. Now, I'm very happy to introduce Professor Barry Costa-Pierce, all the way from University of New England in the US. Professor Costa-Pierce is an international leading scientist and fisheries in aquaculture who conducts research on the development of sustainable systems for aquaculture from a holistic perspective. He often applies a multidisciplinary approach, including ecological, economic, and social aspects of sustainability. He is one of the pioneers of ecological aquaculture and participating to developing FAO's ecosystems approach to aquaculture. He is now guest professor at the University of Gothenburg and worked there with our dear colleagues at sjömat. In 2017, he was appointed holder of the KSLA Wallenberg professorship, and tomorrow he will give a keynote speech at the KSLA seminar on sustainable aquaculture on local and global scales. But today we have the honor to welcome you here at SLU, Barry, and to listen to your presentation about integrated agriculture, aquaculture, energy, ecosystems. Welcome. The floor is yours.
So thank you for that generous introduction. And I hope this is my first time here. Okay?
No.
It's not okay?
It's not okay. Maybe you should have mine. Take mine instead. Okay.
Something that let's say is put here.
I put it here just in case.
Okay. Let's put it there. Okay. Nope, it's not working. I guess it doesn't like my pocket.
No.
Okay, take this one. Technical difficulties. Okay. We know this one works.
You just hand me over the ears.
Okay.
Yeah?
Oh, good.
No, I think it's better.
Thank you.
Yeah?
Okay. Well, thank you, Anna Norman. Cheers. My first time to SLU. Although I visited you in Lysekil when I lived in Kristineberg for 6 wonderful months on the West Coast. And I fell in love with Shano and Kristineberg and met some very exciting people in aquaculture in that time that I spent in Gothenburg. And so today what I'm going to do is I'm going to give you a very, very broad overview of ecosystems ecology approaches to the development of sustainable marine aquaculture. And what I'm going to try to do is cover it from local to global scales, because I'm a firm belief that what we do locally actually tracks globally in many parts of the world. and hopefully be a little bit provocative about, since I'm in an agricultural university, be provocative about sort of the future of food. Because I notice that's where you're going also, and where the world is going. I'm going to set the stage a little bit. Maybe set the stage of some of this that you already know about the challenges that the world is going to face in the next 50 years to 2050 and beyond to 2100. But I'm going to present it maybe in a different way, because we are in the Anthropocene, right? The new geological epoch where humanity has in its very hands sort of the destiny of this planet in many different ways. We affect every biogeochemical cycle, the very climate of the planet, as well as, some people say, the evolution of the biota and the very biodiversity. The very nut of life now we have in our hands. So what I did during my Wallenberg professorship is that I built upon a talk that I gave at the World Nutrition Forum. And again, very provocative, because most of the venues that I speak to, food venues, are dominated by terrestrial and agricultural scientists. And so this talk is going to try to convince you why we need to change as a species. And we need to change very, very quickly. Not only do we need to get a grip on what we're doing to the world's climate, we need to get a grip on what we're doing to the world's terrestrial sphere. And I feel strongly the ocean can save the land. Okay, so that is available. I can send you the PDF. And these are the 3 papers that are coming out of the Wallenberg professorship. And you can see, again, very broad, almost bordering on preaching to the world. Okay, so our planet is affected by these 2 driving forces: climate change and social change.
I'm sorry, Barry.
Yes.
I think we need to ask people on different locations to turn off their mics,
okay,
so we don't have this singing sound.
Hi, could you mute your mics, please? Our friends there out of different locations. Okay.
It's gone. Thanks.
Okay. So if we look back in the Rio Convention, some of those were good ideas that the first woman prime minister of Norway, Gro Brundtland, had back at the Rio Convention. Okay, she pioneered that great global declaration, and these are the 5 great issues back in the Rio Convention in 2000: food, energy, water, waste, and shelter. So we're going to be dealing with this for the rest of my life and for, I think, the rest of your lives. The challenges that all of these present individually, and as many of us in the academies, we get siloed in these. What I'm going to try to convince you that the real future, in order to make some sort of iterative progress, not like change, climate change is a big thing, social change is a big thing. Some people would call them wicked problems. And all you can do with a wicked problem is to make iterative changes, small steps along the way. One of the things that people get confused about with sustainability is they ask the question, are you sustainable or are you not? Sustainability is not black and white. It's, are you on a path? Are you on a road towards being better? So in each one of these cases, what I want to do is offer you some alternatives on how we can walk the pathway to be better over time, that we know we're going in the right direction. Because in some of these cases, we're going in the terribly horrible, bad directions. Okay, so the first bit of data is something that you do know, but it shocked me. We all knew there was going to be a planet of about 10 billion, okay, in your lifetime. But we didn't know that population was going to not stabilize. That was different. There was a lot of data coming out around the turn of the century saying, oh, by the way, with the one-child policy in China and with growing affluence, that the people on the planet were having less children. And that's not true. But it's the distribution of the population is even more interesting, okay? So we're going to be prepared for 10 billion, and upwards of 12 billion. Okay, the distribution of the world's population is not all the same. indeed, I put the globe now, because the globe, as you noticed, was in that previous slide. That globe was pointed towards Europe, North America, and the Atlantic Ocean. And now it's shifted because of this mega shift in population that we're going to see. So what you see there is that Europe actually will shrink in population. North America will, or the Americas, Latin America and South America, will grow a bit, but the real growth is going to be in Africa, in Mother Africa, okay? And the largest amount of people on the planet are going to be in Asia, and they're going to add population. But look at this down here. You know, India is projected to surpass China as the world's most populous country in 2020. Okay, so we're dealing with these like super nations of mega populations. And most of those the people in the world are going to be in urban areas, urban coastal cities, shall we say. Europe actually has an initiative in many countries, Germany has it, called the Shrinking Cities Initiative, where the world's cities, very few people, less and less people. By 2030, less people are going to live in cities of 750,000 or smaller than ever before. Most of the people of the world will be living in cities above 750,000 inhabitants. And most of those people are on the coast. So one of the things that you and I share in many jurisdictions throughout this planet right now is a vast depopulation of rural areas. Vast. And people flooding to the cities. There was a recent study done by the University of Pennsylvania in the United States asking people of 35 years and younger where they wanted to live, and everyone wanted to live in an urban area or a peri-urban area. They didn't, the data were alarming. And so I come from a very, very rural state. And that has led to massive social, political polarization. And we're all dealing with this. All countries of the world right now is facing dramatic socio-political changes. They're occurring because of these demographics. Okay, the other thing is that the world has become much, much more affluent. Some people even call it's a new disease, affluenza. There's no more North and South division anymore. I'm the executive director of the University of New England's Institute for North Atlantic Studies, called UNE North. We frequently, thank heavens, come to the Nordic countries to learn as part of the learning community. When we go to the Arctic Circle's assemblies, etc., we find people from Korea, China, Japan, Russia, all over the southern countries of Brazil, South Africa. There is no north-south divide anymore. The world is not, it has a tremendous change going on in the world, which were formerly developing countries now developing so rapidly and becoming more mobile. Their middle classes are growing. So this is something that you probably don't know. It's an interesting study was just last year, a global tipping point. Half of the world's middle classes is now middle class or wealthier. So the largest growth of classes, of economic classes, the poor, the vulnerable, the middle class, and the rich of the world, put everybody together. And you give some ideas of what it means to be rich and middle class. The vulnerable and the number of poor are going to decrease dramatically, and the middle class of the world is going to have huge amounts of potential expendable wealth. We're seeing this now everywhere. We're seeing this new middle class being very, very mobile throughout the world. Particularly Asia and Africa's growing, rapidly growing middle class, and becoming very, very mobile. Demanding things like farm salmon, demanding things of luxury goods that we have only desired because we had expendable income. This is going to be a major driver for food. Food is going to, will these people eat beef, pork, chickens? What will they eat? And what will that mean? Will they switch to a completely vegan diet? I doubt it. So what does that mean for planning for the future of food? Okay, so this is shift again. This shift that we've all gone through, it's gone on in my lifetime, where we looked at the world like that in 2018, and this is the new world. If our countries are going to be then supporting this new world, and this new world is going to be demanding more and more of the kinds of foods that we eat and the diversity of foods that we eat, what does that mean? Okay, so FAO says it. You know, we all know this challenge. I don't need to linger on this. You know that it's going to be a real big challenge. This 2100, you know, that's with the 10 to 12 billion. Okay, so maybe this is something that we can all agree to, that we need to accelerate and demand food for growing populations of humanity, but real good food, yeah? Real good food for human health and wellness. That's what we're all about. Healthy people, healthy aging, you know, healthy food, not food that causes diseases and further problems. Okay, let's go to the ocean. So a couple things about seafood or aquatic foods, because it can be lakes and reservoirs and rivers, right, as well as oceans or seas. This is the world's most widely traded food commodity. Seafood is the world's most widely traded food commodity. There is more seafood in the bellies of 747s of the planet than there is luggage. There's more seafood daily going out of Reykjavik to Beijing than there is of any other commodity being traded right now. So, we have a growing demand for seafood, with 2 billion people on the planet right now depending upon seafood, and Asians eat much more per capita per annum seafood than we could ever hope to. Almost 10 times that we do. And as affluence keeps on going up, you're seeing seafood consumption rates go up and up and up, not only in Asia, but along the countries of the Great Rift Valley in Africa, where most of their protein foods comes from aquatic foods, not terrestrial foods. If you ask them, they would prefer to eat aquatic foods rather than terrestrial foods. In West Africa, very similarly, along the entire Sahel region, down through Nigeria, people want to eat seafood. So we have 5 ways, okay? We're going to have to do all of these. So for me as a scientist, I can't just be in aquaculture, because I can't define the future of food in Mother Ocean by the destruction of capture fisheries. That's not something that we need to do. We need to sort of say, we need to work together to restore marine ecosystems and habitats and restore fisheries. And I think that the aquaculture toolbox can help restore Mother Nature, as well as restore marine fisheries. There's many examples of that. But we get stovepiped. The management, the policy, the legal, the regulatory environment about the ocean is controlled mostly by fishery scientists who do stock assessments, etc. They don't know anything about aquaculture. And so we're faced with a lot of these big challenges. So there are, in each of these 4, there are some really good inventions that are happening. If you go to Iceland, you will see fabulous water laser cutting machines to increase the processing efficiencies beyond our wildest dreams. And these are no longer menial jobs of poor people like standing in front of a production line. These are jobs of PhDs running computers, putting more food, good food on the table. So the future of processing has changed completely. So, but everybody says this. Everybody says this. So how are we going to do this? How are we going to increase aquaculture? Okay, first of all, why? Why would we want to increase aquaculture? It's because of people. Okay? Look at these 3 studies. If you gather what we call the seafood doctors, they tell people, women of childbearing age, women who want to become, bear children, vulnerable people, older people, they say, eat more seafood. It's got these amazing miracle compounds in it. Not just DHA and EPA, not just omega-3s. It's got all of these unusual trace elements. We supposedly, in our evolution, came from the sea. In the United States, half of the people are iodine deficient. Because it's a big sort of inland country, right? It's got a huge inland area. You find the same thing in Africa. And it's because there's not enough consumption of the wide variety of seafoods that built us as intelligent human beings. It built our brain, okay? So some of this stuff is just mind-blowing. I mean, it's like, for you, you go to a doctor, instead of giving you a pill, he says, eat more seafood, okay? Okay, so this is a fairly major global consensus, which is very neglected, I think, by a lot of our friends in agriculture, okay? Is that this aquaculture, just because of its fundamentals, you know, the animals are grown in water, so they don't have to have a very high bone density versus meat, you know, they don't have to sort of prop them up from gravity. You know, they're cold-blooded, they're much more efficient than any other terrestrial land animal. Okay, let's look at this data. You know, this is famous, and I go to all these aquaculture conferences, it just came from one with 3,000 people, and everybody's up to this graph. And what happens is they over-exaggerate. That's my take-home message to you. It's really, you look at a big number. But what does that number mean? What is 67 million metric tons? Well, first thing, this is what you see is that capture fisheries, and that's what you think is capture fisheries in your mind, I bet, which is boats running around with big nets killing fish. And then aquaculture, but you probably only, some of you might even have a problem, or not you, because you're aquaculture people, but certainly the public that I talk to, you know, they think when you say aquaculture, look, farmed salmon in Norway, that's it, okay? And they forget about all the different products. And by the way, you see that one above the 7 there? That's 30 million metric tons of that aquaculture. That's carps in China. Carps. How many people just ate a carp? None of you. Okay, you did. You ate a carp. I like it. I like it. So, but let's break this down. Is first thing you see, I mean, I'm just giving you the conventional wisdom right now. Capture fisheries is flat, not growing. By the way, again, you don't need that to go down any further. We need to work together, maintain that level. But you notice that aquaculture is growing rapidly. But let's put it into perspective of something that the agriculture people know. It's really tiny. It's, you know, look at this is maize or corn, wheat, rice, and soybeans. Oh, great, we just smoked barley. You know, we're better than barley. Okay? Keep that in mind. Now, you need to break that fisheries and aquaculture thing up a little bit. Because let's look at it in terms of meat. So not bad, fisheries and aquaculture. We're going to take out seaweeds out of that. We're going to take seaweeds out of fisheries and aquaculture data. So we're a little bit better than beef. Certainly nowhere near chickens. What do you think yogurt consumption in the world is? It's about 400 million metric tons. Okay, so 71% of planet Earth only produces about 4% of all human foods right now. 71% of the planet, only about 4% of all human foods. That's what that data means. Oh, and how are we doing with aquaculture? Not that well. So that big number up there, right? Look at that. Oh, aquaculture is growing everywhere. 62% of this lower part, 62% of all aquaculture in the world today is in one country, China. 90% of all aquaculture in the world today is in Asia. That's it. Right here, that line going down, that's the rest of the developed world. That's aquaculture in the rest of the developed world. So do not let anybody tell you that aquaculture is you're eating 1 out of every 2 fish. It says you hear these over-exaggerations everywhere. Aquaculture is rare everywhere. It's still pioneering. It's very hard to find, except for Asia. That's it. Okay, so here's another way of looking at it. There's 90% of it. So pretty much all of the other countries of the world have no aquaculture. Why? You've been asking yourself, why is this? Okay, how about Sweden? How about Sweden? So this is the 28 to 2015. This is all of Europe. All of Europe is only 1 metric ton. And it's gone down. Now, a little bit of European, the 28 nations of the EU are making progress, some of them. But Sweden here, only 5 or 6% of its total fisheries is aquaculture. This is an interesting graph because you see, interesting table because you see the Czech Republic, which is fascinating, right? 100% of its total aquaculture production, which is only 20,000 tons, is from aquaculture. How many people have been to the Czech Republic to see what aquaculture is in the Czech Republic? Beautiful, wonderful. So you know it's the big, old, traditional carp ponds, and you have to have a carp for Christmas, and all the markets are going to just carp for Christmas. So what I've decided to do in one of my papers is to break up the world and to make it feel like, in terms of aquaculture. The aquaculturally developed countries, the aquaculturally developing countries, and the aquaculture least developed countries. Sorry, that's Sweden. Okay, so these are the criteria that I use. So you can see it, production criteria, some governance systems, knowledge systems development, and value chains development. If you're an aquaculturally developed country, you've pretty much got a very, very robust investment, and you can see you produce a lot. Okay, so how are we doing? Now, this is world seafood trade. And I decided to put these countries together in world seafood trade. And you see, it's interesting. Sweden comes up in the top countries in the world as one of the largest importing nations. And it's an aquaculture least developed country. Interesting. How about the United States of America? It is a huge importing country. And it's an aquaculture developing country. So all the developed countries, China, Norway, Vietnam, Thailand, Chile, India, Japan, China, and Korea. Pretty much all of Asia, with one interesting exception, your neighbor. Okay, so there's been some people looking at this that are food justice people. I hang out with them sometimes, and they say, if this was agricultural products, we would say that these particular countries are outsourcing their environmental impact. They're outsourcing their ecosystem impacts. They're not only outsourcing, they're also having some fairly interesting ethical impacts. So the United States in this particular context, with that amount of importing nations, that amount of imported seafood, is not deciding to develop aquaculture in its own jurisdiction, and therefore goes to other countries to take most of their protein, because it's a rich country, to take their protein from who? Who is it taking it from? Is it taking it from poor people? Does it have good food justice to it? Big questions here. So every country there that decides not to do aquaculture has to be asking themselves those ethical questions. Okay, so this is what aquaculture looks like in some parts of China. I was in Qingdao in October, and I saw lots of this everywhere I went. So is this what we're going to have? I doubt it. So we're going to need an alternative path, okay? Because we need room for marine mammals. We need room for nature. We care deeply, deeply about ecosystems. Okay, so we need a model. Okay, so I'm not the first person to come up with this idea of ecological aquaculture. I first met this guy who wrote I'm an ecologist, and he wrote the classic book, Eugene Odom, Fundamentals of Ecology. And he's the first one to mention ecological aquaculture. But ecology is an adjective in front of aquaculture, and look at it from an ecosystems perspective. And then the first paper even mentioning it was this guy, Ken Mackay, who eventually became my boss at the World Fish Center in Penang, in Malaysia. And he wrote that paper in, 1983? Okay, so this is something that you're not supposed to do as a teacher. You're not supposed to read the slide, so I will. Okay. So it merges the use of ecological principles and practices, so very Odom-esque, principles and practices, such as ecological design. Now that's interesting. In Svimark, we have a designer from Tongji University. He's a graduate school of design. Okay, so ecosystem design. Okay, ecological engineering. Ecological engineering is a big field. It has its own journal of ecological engineering. You'll see aquaculture people publishing in that. And ecological, there's one more, there should be ecological economics, which is another one, and ecological approaches to management. The understanding, this is important, because people matter, the ecological understanding of the social ecology of aquatic foods and farming families, communities, and regions, all scales of society. I do backyard aquaculture in my backyard. I also do it at the level of working with farms, and I'm also interested in these larger issues. Okay, so the goal is to create and sustain innovative, economically and socially viable aquaculture ecosystems at all scales of society. Okay, so how did this happen? Well, the Food and Agriculture Organization of the United Nations first came up with this pioneering study which developed the Code of Conduct for Responsible Fishing. So the FAO Code of Conduct for Responsible Fishing was a big, big event. And so many nations in the world say they hold to the Code of Conduct for Responsible Fishing. And then we all got together in Spain, brought together by FAO, toasted the FAO ecosystems approach to aquaculture. Why is this important? Many jurisdictions in the world, let's give you one, Mozambique. Mozambique has a fabulous potential for aquaculture. It has a giant long coastline, has inland lakes, has a fish-eating people derived a lot from the Portuguese. Portuguese eat a lot more fish than the average European. And so Mozambique routinely gets proposals from foreigners, primarily, promising jobs and economic development for aquaculture. And invariably, when those proposals come forward, the Mozambican management authorities may be confused, they may be overrun by the glittery promises of foods, jobs, economic development from aquaculture. Instead, if the Mozambican government then says, oh, but that's great, foreign investors. You're going to give us food, jobs, and economic development. But do you hold to the Code of Conduct for an ecosystems approach to aquaculture, big foreign investors? And if they get confused and they say, well, Mozambique can say, well, we hold to that. We hold to the FAO Global United Nations Compact on an ecosystems approach. Go back and do your study again, because we want to see how you're going to meet some of these ideals. So they can say no. If you, even at in an industry level, they could say, no, we're not going to accept your investment unless you hold to this global compact. Okay, so you can see that everything I've basically told you about in the FAO stuff is all available on the web. And it uses these great words that we all know about. You know about this from agriculture, right? People matter. I say to my marine science friends, people are not plankton. You study your plankton, I get it, but that's not people. So you've got to get some process together on an ecosystem approach that uses those words and shows us how you're going to involve people in the process. And it's a big word. All these beautiful words down here in the bottom that we all know about, right? But it's a strategy. How did you do it? How did you involve people? What's your plans to involve people? And what's interesting, you'll start to see some of my friends are in sort of the participatory approach to developing ecological aquaculture. They publish now in journals like Conservation Biology. So you'll see some of this, people running these large processes, publishing their participatory processes in the finest journals on the planet. Okay, so back when I was the age of some of you in the audience, much younger, this is what, if I could get mommy and daddy together, and they could produce babies, otherwise known as seed, I could get brood fish together, or gravid males and females, right? Okay, let's speak because we're in a scientific setting. And I could feed them, and I could sell them. I'd be a success. And that was a real 1970s, 1980s strategy of aquaculture. Really just grunting it out. But this is the ecosystem approach to aquaculture. You can't be in aquaculture feeds today and not be involved with agriculture or ingredients or with fisheries. And you look at opportunity costs, you can't neglect economics. And so these days, this is the training portfolio for the future of ocean foods, right? Is you must pay attention. Your success will only be present is when you have taken into account all of these different factors. And if you looked at a recent paper in bioscience by one of the world's largest nature organizations, the Nature Conservancy, they're basically sort of saying, this can all be done. Aquaculture can be a really, really part of nature preservation and nature reclamation. Okay, so this is some of the things, these modern fields that we're bringing to aquaculture. And each one of them, as I've mentioned, has its own journals and transdisciplinary silos. Back in the day, there used to be sort of biology, chemistry, physics, and those groups hardly ever talked to each other with the social sciences or the historians. They all were in the academic silos. Now we actually have transdisciplinary silos, which is really funny, because you get the ecological economists who only talk to each other, and the ecological governance people who have their own societies now. But it's getting better. But putting these together in the context of aquaculture is absolutely fascinating, because we can do this. We can actually grow lots of food with much less impact on society and not destroy nature. So is agriculture doing that on an industrial scale? I don't know. Okay, some examples. I'm going to go into some examples. Now, I call these C systems. Everybody's going to have their own fancy acronym, right? So I call them C systems, Sustainable Ecological Aquaculture Systems. I made that up. So since we're inland, I want to talk about all of the possibilities of inland aquaculture systems or land-based systems. But I really want to give this all a food systems perspective. Don't let that go away, because it's just like one of the things that I've learned is a lot from our friends doing food systems inland. There are people doing food systems inland, or agriculture food systems. They've got like a 30 or 40, maybe 50-year head start on us. We're only just beginning. So we got a lot to learn. So I've been going to a lot of agriculture food systems meetings to try to learn of how we can bring that over to the ocean and aquatic food systems. Okay, first thing, sorry table, just look at the circles. Don't forget that most world aquaculture is freshwater in inland areas, in ponds still. Sorry, it's not salmon. Salmon is only 1 to 3 million metric tons a year. It's even though it dominates the north here, particularly, it's very small. Most of world aquaculture, look at this table. So 44% of all of Chinese aquaculture is inland. India, 90%. 73% Vietnam, 100% Egypt. Egypt is actually a major grower now these days of tilapia. But it's all, even though Egypt has a great coast, Alexandria and all of that area along the Med, but it does no sort of marine aquaculture. It's very small. And look at Brazil, an up-and-coming country. 85% of all Brazilian aquaculture is in freshwater. And you all know how long of a coast Brazil has and how much potential. Okay, so couple of things. There is, in my agriculture friends, there's a giant debate right now about the future of food, as you probably know. And they keep on saying it's going to be sustainable intensification is going to be the key to the future of food. Well, if you put the data together, what you'll find is that sustainable intensification almost requires that everybody does it. Everybody has to do sustainable intensification, or it still doesn't work. And the other thing is that there are very serious constraints to sustainable intensification on land. With one exception, almost every single proposal being made by the agricultural scientists of the world today does not include aquaculture as a part of sustainable intensification. It's rare, and you see these scenes all over Asia. Now, how did Asia, sort of retain its food security? It's because most of these systems were integrated agriculture, aquaculture, farming systems. What do plants need that aquaculture can provide in spades? Rich, nutrient-rich, warm water to irrigate plants. The Asians knew this 1,000 years ago. There's nothing new about this. So that's the first question I'm asking to my sustainable agriculture friends. Your proposals for the planet for inland will fail unless they're integrated agriculture, aquaculture, farming systems. So these are beautiful systems. They're, some people, Bill Mollison years ago called them permaculture. Okay, some of these are thousands of years old in Asia, been farmed continuously, nutrient-rich muds put up on the land, and you can see 3-story farming systems, all fed off of nutrient-rich ag waters. By the way, those of you who know something about gardening, have you ever seen, like, when you take cold well water and you put it on your crops, you shock them, and they grow slower for about a day? Well, how about if you used warm, nutrient-rich water from a pond to irrigate? And that's what these people do. They learn that. So the wisdom of farming societies over 1,000, 2,000 years. So these are the systems that we developed in Africa with our many, many African universities and friends with a group called the World Fish Center. The World Fish Center, based in Penang, Malaysia. They're also based in Zambia. They're based in many places in the world. What I love the World Fish Center is they're just not yet another bilateral donor, like Swedish CETA, like USAID, like ODA in the UK, which go for 3 years, they give you 3 years of money and say, change the world. And World Fish Center gets its money over the longest period of time to employ international scientists from throughout the world for 50 years, 80 years, okay? So, and they're based to build capacity in these countries, not just one-offs. So this is, you do a farming systems diagram, a farming systems diagnosis. You get to know people, and then you begin to put plans in front of them, that are ecosystem thoughtful, ecosystem designs. So this is not fanciful. There's many, many papers on this now showing that, particularly in some of these ecosystems in Asia and in sub-Saharan Africa, that the farmers earn more money by doing this. They're more resilient. They're more resilient to climate change, etc. So that's where aquaculture means a thoughtful process of water and how it integrates across the landscape and how fish and fish manure and fish waste can be processed. Okay, so that's the sort of local small scale. What's some of the really cool things going on in our countries right now? Well, one of them started with this guy, James Ricosi. He wrote a chapter in my book. It's up there. And he was one of the first pioneers to sort of think about sort of large-scale aquaponics. And you can see him up there. He taught many courses over about a 20-year period out of the University of the Virgin Islands in St. Croix, brought people from all over the world. Basically, what Jim did is that he had an aquaculture. This is now decoupled aquaponics. You'll see many, many people in the pioneering stages of aquaponics. They put the plants on top of the fish, and they tried to integrate them and everything. That was a bad idea. I mean, it's a cool idea to do for elementary school and for education purposes, but it's not a good idea for production. And the reason is that it's really hard to optimize the conditions for fish and optimize the conditions for plants when they're in the same system, okay? That's very, very hard in order to get optimal production. So what Jim did is he started decouple aquaponics, growing large amounts of fish, and then using a waste treatment idea, or what was even cooler. In this sump, he actually took So it not only looked at, there was an animal agriculture part of this, but he's the first one that came up with like a 3-to-1 ratio. because there's so much nitrogen in these tanks. I mean, from the fish. We feed fish a lot. Fish poop a lot. Fish excrete a lot. And so there's a lot of waste. And we found in the initial stages that it took almost 3 times the area of plants to take up all of the waste nitrogen from the fish. This is very pioneering. But now what's starting to happen is large-scale aquaponics, and it's really, really exciting. So this is, I'm going to spend a little bit of time with this one with you, because this is in a climate similar to Umea or Luleå, way up north, okay? It's in way up north in northern Wisconsin on the Canadian border, and it's not a dream. Just about 3 to 1 again. Here's the big now, inland salmon. Inland salmon. This is not trout. These are Atlantic salmon, right here, not in fresh water. And then this is the large greenhouse. Let's look at some of the production statistics. This is just from last year's production. They've had many years of production. So these are the sizes, and this is the total size of the facility in square meters. This is the production of fish, plants, and total production. That's 889 metric tons. And this is the productivity. Now, that's a little bit low. You'll see in salmon culture and net pens in Norway getting up about 50. Okay, but it's still pretty good. But this is what blew me away. Take this production in salmon. Food conversion ratios for salmon, if you use spreading and use a high-energy feed, they're about 1 to 1, which they're using. That means it took about 79.9 metric tons of feed to not only produce this, but also to produce this. These are not fed. There's no nitrogen going. There's all this fish nitrogen. That means 79.9 metric tons of feed produce 889 metric tons of human food, or a feed-to-food ratio of 0.09. That means that 1 kilogram of fish food produced 11 kilograms of food for human consumption. Wow. In a northern area, in the winter, it runs all winter. So these systems now have this kind of potential for inland areas throughout the world. This is the most sophisticated, this is the largest aquaponic facility in the world. And so we can bring this kind of good food inland. Now these are leafy greens. This is mostly like fish there and leafy greens there. So go on and get a YouTube on Superior Fresh and look at some of what they're doing. And you're going to start seeing these popping up really everywhere on the inland areas of the world. Okay. Another big opportunity is urban aquaculture. If most people are going to be living in urban areas, then we got to think this through. And there's some really good examples of this in Sweden, by the way. There's a grower in Gothenburg who's doing some fabulous work in this area. But probably the best in the world today is what the Indonesians are doing. And they are taking small-scale urban aquaponics to a very, very high level. And you'll see these words in Bahasa Indonesia, bulimia and nunemia. And these are these kinds of systems where they've engineered in a farmer-smart way the pond together with potted plants. And they're extremely productive. And they're really becoming the most popular systems in Indonesian small backyards. Okay, let's go to the ocean. Hang with me just a little bit longer. So, again, a parallel, ocean food systems. It's a lot of space out there, but when we look out over the ocean, oftentimes we forget, being a terrestrial being, we forget that it's pretty crowded out there. If you put all the ocean uses on a map, you'll see there's not a lot of area still left for the newcomer, aquaculture. Okay, so these two have caught a lot of attention, shellfish in the world. They're some of the world's largest aquaculture industries. But you probably think about these guys, as some people think about them, as aquatic cows. You need plankton, you need phytoplankton in order to feed them. Aquatic cows, they're grazers. Nothing could be further from the truth. So this is really what they eat. They eat not only a lot of phytoplankton, they eat a lot of detritus. Unconsolidated organic matter comes from dead and dying material in the ocean, or what some people would call marine snow. So we've been on this for a while. We found out in ponds, we found out that the ponds are actually heterotrophic, and most of the production is actually coming from bacteria. We found that with tilapia in a big ocean in Southern California that most of the tilapia were being fed by detritus and not by plankton. And just recently, we've looked at the carrying capacity for shellfish in many lagoons. And we found out that most of the shellfish in those lagoons are eating detritus. Goodness. Does that mean that we've been working on shellfish for over 200 years as scientists and we didn't know what they ate? And that gives you some sort of idea of how pioneering and how primitive aquaculture still is today. Okay? There's still all these things to be discovered. And one of the great ones is detritus. Now let's go further. How big is this? This is really big. Because the ocean has something called a thermocline. That thermocline is a density discontinuity that is present much higher in the water column in the summer. Density discontinuity. That means that the warm water is up in the top and the cold water is on the bottom. It actually creates a discontinuity layer which captures the particles. Detritus. And they actually, in a layer, we can see them, is a detrital max. But what's interesting is that if you did a total protein analysis of the water column, you would find it's a protein max. It's not just a particle max. It's huge amounts of protein. Microbial protein. Food. So this is the largest food source on the planet. It's detrital protein caught in the thermoclines of the world's oceans. So can we poise aquaculture systems in a smart way there and harvest huge amounts of human food, particularly from shellfish? Question. Okay, so we've been involved in this for a while now because this is a miracle plant. Oh, it's a plant, sorry. That's gracious. It's an algae. Imagine something that grows in the coldest times of the year with hardly any light, that needs no nutrients at all, and produces phenomenal production of great human food. And these, welcome to the marine algae. So we've been working, and I'll go through this fairly quickly, for about 5 years now on marine algal seaweed. So people, it's not a weed, we don't call them weeds anymore, we call them vegetables, sea vegetables. So our friends in Asia, again, they're way far ahead of us. Over 90% of all sea vegetable farming in the world is in Asia. So we got a lot to learn. But it's interesting, when we start putting our ocean engineers on this, they've come up with some pretty dramatic changes. So how about this one? This one just came to me recently from the University of Southern Denmark, where basically this scientist is saying, our consumptions, she studies the human brain, okay? Well, not the, she's this Lynn Cornish, she studies the human brain. And the development of the human brain and some parts of it can be directly traced to our consumption of seaweeds in our past as species. It takes just 300 milligrams of consumption of Saccharomyces to get all of your daily needs of iodine, and it's organic iodine. And most of the people in this planet are severely depleted from the trace minerals and iodine that is in these plants. Okay, so this is what we've been doing. We basically did the entire aquaculture cycle. We learned how to do it. And we're not alone. There's people, obviously, Sintef and Ofima in Norway are very far ahead in large scale. What we wanted to do is to do it as a livelihood supplement for our coastal fishing families. Our coastal fishing families, because of massive climate change, they used to, in the winter, fish these beautiful pandalic shrimp that Sweden is so blessed with, that you have, abundance of those little tasty little shrimp. They're gone from our coast because of climate change, and that there disappeared the winter income for almost all of our fishing community. So now they're kelping because the markets have grown so fast, and we can grow these in the winter. we're getting all of these fishermen and fishing families involved in kelp farming in the winter. They know how to do winter. Okay, they grow fast. Again, we're at a point where we can do about 15 kilograms per meter of line, and we can get about a ton. We can get about a ton in one season. That's good, because when we dry it down, 90% water, that 100 kilograms or so is worth $40 a kilogram. That's $4,000 US in one season. Not bad, from one line, okay? And we've made it so that we can do a farm in a box. We could put everything out there in a small skiff, very low cost, all of understandable to the fishing community, and get them out there. And the food market is really growing in this area. And in the future, this is what it looks like. You can see that all you have is tiny little buoys at the water surface. So it's not visually impairing the water surface as much as you would think. And we're moving up in scale, and we're going further offshore. And that's our new system that we're putting out. It's about 4 hectares, that size. These are very, very productive for human food. And that's our first step. However, our friends at DTU in Denmark, or also KTH in Stockholm, they're working on the next stage of the blue bioeconomy in seaweeds to replace all single-use plastics, all packaging, even making, as we show here, well, no, I'll show you here. I'll go back to this one. Right there, shoes. Making shoes out of seaweeds. Some of the molecules that are in Saccharina lotissima, they've been able to make stronger than nylon. And so we have the possibility now to remove all of that marine pollution if we can move this into seaweed biomanufacturing. So not only human health and wellness, but the whole change of industrial ecology. When I was at KTH, I met a couple of 2 or 3 of their PhD students doing PhDs in industrial ecology in seaweeds, which was one of the most hopeful things I've seen. And yes, of course, you can make beer out of anything. Okay, so this market is growing. This is our 3,800 kilometers of coast. The last dot there is our friends in Canada. We are very strong. Our economy looks north to Montreal as much as it does to Boston and New York, and there's all kinds of... This is the largest buyer. What's great is that fishermen, when they come into port, what they want you to do is peel off cash. That's all they want. And so they peel off about a ton. Buyer just gives them cash and they drive off. So it's working. It's working in many ways, and the products are going into all kinds of high-end supermarkets. And then we get the chefs. The chefs are a market driver. When I was in Shano, in Christina's Shano, Sweemark had a scary seafood symposium with the public out there. And they, in Shano, University of Gothenburg has a 4-hectare seaweed farm. And they've been getting together with the chefs, sort of looking at becoming a market engine. And then we've had people, we now have festivals. We have so many farms that people show up and they look at all of the varieties and other products coming out of seaweeds. Now, this is also affecting every pharmaceuticals, skin creams, cosmetics. You know, by the way, if you brush your teeth this morning, you ate seaweeds, or hopefully you didn't swallow your toothbrush. That's why you're using toothpaste. Because carrageenan in toothpaste, that all comes from seaweeds. It all comes from Tapophycus throughout the world. So whether you knew it or not, you use seaweeds today. Okay. So I want to talk about the other example from the ocean is, I notice I'm doing the lower trophic level species, okay? And what's interesting is because seaweeds slough off about 20 to 30% of all of their primary production is actually released either as mucus or as breaks off. And that sort of churns up in the ocean and causes detritus, which is good food for bivalves. So what's interesting is that there's a lot of farmers who now have realized, and this comes directly from marine biology, they realize that seaweed, if you go out into nature, you find the most productive shellfish beds are downstream from seaweeds. So now you're starting to see a lot of farms, forget about salmon, lower trophic level integrated farms. Okay. So, I'm going to start wrapping up here. This is our common goal at all levels of societies. So, I've given you some examples. So, how are we going to do this? So, what would the future bring if we start thinking this all the way through? So, not just merge agriculture, aquaculture, farming systems, polyculture, marine systems. We'd start seeing this. We'd start seeing combined energy food systems. This is interesting. This is a big commercial carp pond in China that we just saw. And then, how about this one? There are plans for massive development of wind power all over the world, not just, this is the Hornsrev in Denmark, not just the UK, but everywhere because of the climate imperative. And there's a lot of structure that's being put out there. So, this is our friend Bela Buck at Aue in Germany, in Bremerhaven. He's come up with this idea that we could not only use the towers, but we could also use the lease areas for combined food and energy systems. And he's been doing this off of Germany for now a few years. But this one really caught my attention. That one's going to cause a lot of problems with the legal, regulatory, and with trying to get the industries together. But when we looked at the legs of these platforms, we saw that they encrust. They obviously develop a biotic community. In this particular case, they developed such a large growth of mussels, of middle sedulous, they were upwards of 3 meters long. If they weren't taken off the legs of the towers, then they would slough down to the bottom to the mud metal line, right there, where they would degrade and start to weaken the towers. They'd provide acid, and the towers would start to get weak. So here's an innovative idea. What is this? Is this a fishery or is this aquaculture? I think it's a fishery. Because this gentleman and his company had an idea that they'd go out there with Venturi pumps and harvest them and sell them up in the open market. So now there's about 200,000 metric tons of mussels harvested off of the wind towers and going into our markets. So there's an evolutionary, some interesting thoughts. You were thinking, this, oh boy, that's really invasive. That's going to take a long time to get everybody on board with that one. We can start this right now. We can start effectively harvesting good food off of the towers right now, and it's a win-win for the energy companies. Okay, so in order to get this done, it's, to me, at this stage of my career, it's all about the young people who are here. You're almost all younger than me. We need to find the next generation of ocean food systems leaders. Not just aquaculture, but ocean food systems who think, broadly and do local to global. Take risks. So this is what we've done in the last few years. We've put together our masters at the University of New England in Maine. It's an ocean food system masters, together with a Nordic masters run out of Swemark as the coordinating agency. And you see we have on this side Bøde and 2 universities in Iceland, Akureyri and Hólar. So a student can have a mobility, complete mobility. They can get supervisors from any of these organizations. They can do their project in any one of these countries. And they can basically do the issues and the problems of the people of the place. A much more applied, stakeholder-driven masters. So that's one of the first things that we've done. And now we're holding courses. We had one in Christineberg. We had 20 people from about 10 nations. And then we did one on my side at my institute in Maine. I put that one there. That's because that's one of the big RAS, recirculating aquaculture systems, that are being funded by Norway in Maine. Okay, so again, capital is fungible. And so everybody's talking about this. Okay, I'm going to start wrapping up. So oftentimes, back to that exaggeration, aquaculture is the most rapidly growing form of agriculture. 1 out of every 2 seafoods that you eat, or 1 out of every 2 kilograms you eat, comes from aquaculture. And I told you that most of that's in carps in China. And it's like, if you know statistics, one of my friends used to say in a case like that, you've got 1 foot in a pot of boiling water and another foot in a bucket of ice water, and on average, you're feeling good. Because that's what we're doing with these, by over-exaggerating these statistics. Aquaculture is still very, very rare everywhere outside of China and some countries in Asia. And all we're actually asking for is just a little bit production up there to increase just a little bit production in our countries. It's not going to be everywhere. We're just asking for a few hectares. Because a few hectares of production on the world's coasts adds huge value. Okay? So marine spatial planning is a real big deal these days for aquaculture. Because you see this, and these figures are not over-exaggerated. This is one case in a case of point where I live. You get these multiplier effects. So the next generation of ocean food systems leaders just can't be over here. Because there's not that many jobs over here. There's not that much money over here. I'm not going to pull you away from doing production for your career. But to neglect all of this, where most of the jobs in economic development and most of the opportunities are over here. So we need like a value chain ecosystem approach, or just not aquaculture, a food systems approach. And I'm not the first person to say this. The Food and Agriculture Organization of the United Nations has been saying this at least for 7 years running in their State of their World Report. The integration of planning and management between the two sectors is vital for our future sustainability. And if you go to the world's largest seafood shows in the world, the Brussels Seafood Show, or the Boston Seafood Show, which actually is being held right now, where $1 billion a day of seafood business is done, this is the way they talk. They don't talk about aquaculture and fisheries. They talk about the whitefish market. If they don't have enough cod and haddock to suffice their whitefish consumer market, they buy pangasius and tilapia from aquaculture, which is completely substitutable in their marketplace for the whitefish market. So these fields interact so intensely that you can't just be in one particular area and sort of have the tunnel vision of just being aquaculture. Okay, and then people. And people in a plankton. So we're making progress, but we don't, particularly here in Sweden, there's been some studies just recently, very, very similar to studies done in other developed countries, which is that the public just does not, we don't have a social contract for aquaculture. That, we lose out. When aquaculture loses out, people go to chicken. Okay? So this is a big deal, is how do we get an accelerated social contract? Now, working with non-governmental organizations, I mentioned Nature Conservancy, World Wildlife Fund, etc. Now, they're helping change the situation. I'll describe how that is changing. And with marine spatial planning, we're starting to get traction. One of the big problems that we've faced is that, and you face it on the West Coast, is that in the summer you have a vast number of immigrants, in particular like the Oslo Norwegian crowd. In our particular case, in many places in the world, you have rich people coming up from the south and populating the northern provinces and the northern states. And when most of these people actually are cottage owners. They don't have maybe deep roots in the community, but they definitely have a wealth and a presence. And what we're finding is that we have not engaged them, that they are opposed tremendously to the residents' proposals for aquaculture development. So engaging people that we normally are outside of our comfort zone is going to be really, really important for the future development of a social contract for aquaculture. And, hello. Okay, so this is part of our research agenda now in marine policy. So I want you to see aquaculture is so broad, so diverse. You can be any kind of person, of any interest area, and you can be involved in the development, not just sort of biology in a lab. And I'm just going to go quickly here because this is a National Academy of Science study on ecosystem concepts for bivalve aquaculture. So we're making a lot of progress in terms of the social contract for shellfish and for seaweeds. Much less so for finfish. Much, much less so. Okay. And restoration aquaculture. There's, as I mentioned, this recent paper in bioscience. There's so many opportunities here for using the wisdom of what we know about fisheries and aquaculture, or I call the aquaculture toolbox, to actually restore some of these wild populations. And some of this is being done in a way that it really is so surprising. Most of this is, the eelgrass that's being planted out there mostly comes from using marine agronomic practices, and it comes directly from fisheries and aquaculture. We can restore every coral reef if we can get the quality of water right, because we can frag all the corals, we can reproduce all the corals and put them out there using the aquaculture toolbox. Okay, so what happens if we don't do the aquaculture imperative? The rest of the world's remaining biodiversity is in just 7 countries on the planet. These countries are going through massive change right now, sociopolitically, etc. And this is what you see. So it's outside Jaboticabal in the Pampas region of Argentina and Brazil. You're starting to see massive amounts of deforestation. So back to sustainable intensification. I feel pretty strongly from the data that I've been able to gather that, I'm biased, I'll admit, that sustainable intensification won't do it. That land clearing is the only way that agriculture purports to solve the world's looming food crisis. Land clearing, which is deforestation. Now, sorry to say, with some of our friends in feeds, as the aquaculture is also responsible for some of this. Let's walk you through on that. In the first part of aquaculture, we talked about fish meal and fish oil. Then we started seeing great concerns about farming up marine food webs. You heard that, where we were destroying the world's clupea fisheries, the anchoveta fisheries. The fish meal and fish oil was a big concern. So what happened is the nutrition has moved away to agricultural meals and oils, to canola, to soybeans. Who drove that was the big soybean industries in the world, particularly the American soybean industry. And they moved to places like this. So as we moved with farm-fed fish into soybeans, aquaculture began to be blamed for deforestation. So we can't be there. We've got to move away from soybean meals and oils and things like that. Because we're having not only this impact, we're also having an impact on fish welfare. We're finding that soybeans causes gastric disturbances. So where do we need to go in the next stage? The next stage is what you're finding is the beginning stages of microbial feeds, fungal feeds, bacterial feeds. And this is happening very, very rapidly. Some of our colleagues at the Norwegian University of Science and Technology have produced fungal feeds on wood chips that are as high a protein as fish meal and have been fed to fish and successfully reared crops of salmon. So you're going to see the future of fed animals moving away from uses of fish meal and fish oil. Now, not complete uses, because there's issues of palatability. There's issues of fish finishing feeds, etc. And maybe the use of new ingredients. Okay. So, if we don't do this, I think every single natural area like the Amazon, like the taiga forests, like the great natural areas and national parks of the world, will all be under threat from advancing agriculture. We're seeing it now to feed people because of dire human needs. So we have to find a way to sustainable farm the ocean. And we need not tens of people, we need thousands of scientists involved in this movement worldwide to sustainably farm the ocean in order to save the rest of the terrestrial sphere of the planet. Thank you.
so much, Barry. It was very inspiring, very, very, very nice presentation. We have now maybe not time for any questions at the moment. Maybe one quick. Someone is very quick. Otherwise, we take a short break, just for 5 minutes, and we gather again, the ones who want, for a more in-depth discussion with Barry. So we meet again at 20 minutes past 1. Yeah.